So good afternoon and good evening to everyone that's joined us. Thanks so much for joining the 2022 Virtual Orchard Meetup series. This is our fourth and final virtual meetup for the season. Just to remind you, this is the second series that we've done for a virtual orchard meetup. And this series has been focused on orchard efficiencies, on labor and technology. Our extension team has included Bernadita Salato from Washington State University, Mario Miranda-Sazo from Cornell Cooperative Extension, Daniel Weber from Penn State University Extension, Christy Grigg-McGuffin from WMEFRA, and myself, Anna Wallace from Michigan State University Extension. So this is part of a 4-part webinar series that has met on Thursdays every other week this summer. And we've gathered a group of panelists for each webinar who are experts and leaders in the industry in both labor and technology. And for this webinar, our panel includes experts from academic institutions from across North America. So tonight we have Inez Hanrahan from the Washington Tree Fruit Research Commission, Long He from Penn State University, Yu Zhang from Cornell University, and Matthew Whiting from Washington State University. And for the next hour and a half, we'll begin with having our panelists introduce themselves and their institution, and the remainder of the time will be used for discussion. So thanks again for joining us. Just to remind you, all of these webinars will be recorded, so we'll have them posted on our extension sites for you to view later or to share with your friends. And with that, I hope you brought lots of questions. I guess we'll start with Inez. Do you want to introduce yourself a little bit more thoroughly? And
yeah, sure. Thanks, Anna. So I'm Inez Hanrahan. I am the Executive Director of the Washington Tree Fruit Research Commission. I've been in this role for the past 4 years. Before that, I was a project manager. My background is in post-harvest physiology, and my husband and I also manage a commercial tree fruit orchard here in Washington, growing cherries, apples, and pears. Thank you for the invitation.
Yeah, thank you for joining us. And then are you next?
Yeah. Good evening, everyone. I'm not sure, maybe good afternoon for some of you joining from the other side of the country. My name is Yu Jiang. I'm currently an assistant professor of systems engineering and data analytics for specialty crops at Cornell University. It's a long title, but basically I'm doing agricultural sensing and robotics and also AI technologies for agriculture in general. Thanks for inviting me to join the panel this evening.
Thanks for being with us. Long, would you introduce yourself next?
Sure. Hi, everyone. So my name is Long He. I am an assistant professor at the Pennsylvania State University. I physically located at a Fruit Research Extension Center in Big River, Pennsylvania. So it's about 2.5 hours from the main campus. So my work mainly focuses on the robotics and automation for special crop production, especially for the tree fruit systems and precision ag technologies for applications in the tree fruit orchards. Thank you for having me.
Thank you. And Matthew, you're last. Thank you. Last but not least.
Sure. Yeah, thanks, Senna. And hello, everybody. I'm Matthew Whiting. I am a full professor and extension specialist. I'm in the Department of Horticulture. I work at Washington State University's Irrigated Agriculture Research and Extension Center, which is in the middle of the Yakima Valley, not too far from Dr. Hanrahan's farm. I am a whole tree physiologist, an applied whole tree physiologist, and I partner a lot with our colleagues at the Center for Precision and Automated Agricultural Systems, also in Prosser, and also play a role in the newly funded NSF Ag Aid or AI Institute for Agriculture, where WSU is the lead institute. So happy to be here. Thanks for your leadership in organizing these webinars. Happy to participate.
Great, thank you so much. So we wanted to begin, as this is the last webinar, to try to round things out and connect the thread of the technology and labor that we've discussed. With last webinar, we discussed what different growers were implementing. We had a panel of growers that had experienced lots of different technologies. There's a big emphasis on irrigation, some data collection, and tonight we have some people that are working on robotics. So if we could begin by talking a little bit more about the specific technologies that you all are developing, some that are being used by growers and some that are brand new and still under research. And in addition to what you're working on, what's the expected time frame for adoption in the industry? How much do you expect it's going to, time is going to take? Maybe how much is it going to cost for commercialization? And what's the role of your university in implementing this kind of technology? So if you could each take a little time, I know some of you have some slides, and elaborate more specifically on your work and what you think the future of this kind of technology might look like.
Ines, we can start with you, Ines. Yeah.
Okay, great. So the Washington Treehouse Research Commission was founded in 1969, so over 50 years ago. And in its inception, the vision was to have this research commission to fund research to ultimately bring automation to orchards. So if we're looking at a timeline, we've been at it for over 50 years. And some people might think we have made lots of progress. Some people might think we have made not so much progress. But recently, the Treehouse Research Commission has focused a lot on technology and technology implementation. And I want to highlight actually 3 different things. I want to talk a little bit about actual robots, and specifically harvest robots. And then I want to talk about some of the international collaborations that we have started. And lastly, we also started a smart orchard. I'm going to just start with the smart orchard. So the smart orchard was started 2 years ago. We've had, at that point, a lot of sensor companies that were starting to approach members of our industry, saying they can sensorize this, that, or the other, specifically irrigation, but also other things. And we haven't had a good chance to basically test those things out. At the same time, of course, we had COVID starting, so that was not maybe good timing. But regardless, we found a willing grower cooperator that we could use to install sensors as a test bed. And we had multiple goals with this orchard. We wanted to make sure that we can compare sensors next to each other, that we give scientists a chance to run experiments on top of this. We wanted to use the orchard as a teaching orchard, both for students and for basically for orchardists. But we also wanted to ultimately, with our goal was, we wanted to bring basically digitalization to the orchard. That means instead of having multiple apps on multiple platforms that somebody can check for this, that, or the other, we wanted to synchronize the data intake, make sure that the right stuff at the right time gets spit out, and ultimately consolidate everything in a dashboard. Since then, we've been able to have a second orchard site and add a lot of different sensors and involve companies and scientists and the extension team. So we feel this whole process was a success in driving these things. And yeah, we're really excited that we have now these 2 orchards and 2 sites. And just in 2 short years, I think we moved a lot from having nothing to having a lot of information available to growers. The next one is, I would say, is these international collaborations. We realized that getting somewhere is not going to be as simple as, okay, let's put a couple of $1,000 on one research project with one scientist at one university and come back a couple of years later and then have something that is ready to go and that somebody can be using for the next 100 years. With technology, it takes a lot more effort, and it also actually basically calls into question what everybody's role in the system is, right? It's not as straightforward anymore that something gets developed at the university and it gets patented and a company takes it up and then eventually it trickles down to the grower. The cycles are a lot faster, and oftentimes it's really important to have a commercial company involved from the beginning. It also takes a lot of money. For example, the harvest robots, each harvest robot probably takes $50 to $100 million from inception to get it to the orchard. And typically, most of the companies that have played in this game so far, they've been able to raise $30 million. So it's really clear to see why they ultimately failed because of that, of that gap. And there's lots of ways to address this gap. I can talk about that a little bit later. But regardless, we have a global harvest automation initiative that we joined together with California, because we understand that a lot of the specialty crops need hand harvest right now. And so it's a problem for everybody. And we also joined a collaboration with the Netherlands. The Netherlands are a leader in technology, also a leader in agricultural research. So this was a very natural fit for us to collaborate. And then lastly, we're really excited that the space of harvest robots is moving along. There's going to be several prototypes from different companies tested in washing orchards this year. And while we can't foresee how long it will take to finally have one commercialized, we're a lot farther down the road than we were just 5 years ago. We're able to now pick apples, or people can pick apples. Now we have to make sure that these robots work basically for 80 days straight, and they can pick at a speed so that the machine at some point will amortize itself. And with this, I think I'm going to leave it, and we can go into some depth later on. Thank you.
Thank you, Ines. Longhee, would you like to go next?
So first, we just kind of briefly answer the question, right? And later on, we will have a chance to present.
Yes, yes.
Okay. Yeah, in terms of the question about...
Sorry, if you can present now to show what you've been working. Yeah.
Okay, sure. So you can see my slides, right?
Yeah.
Okay. So today I mainly talk a little bit about some automation, orchard automation works at Penn State that I involved. So I have first a little introduction about myself. I'm Longhee, as I mentioned earlier. So I'm an assistant professor in agriculture and biological engineering. So I have 60% of research appointment and also 40% extension. So my affiliation is Department of Agriculture and Biological Engineering, but I physically look at a full research extension center in Bakerville, PA. So here you can see in the center here is the Penn State main campus, and I actually reside here at the very southern part of PA. It's a fruit belt in Pennsylvania. We have about 180 acres of land here at the research center, and I run a lab and also a machine engineering shop here. So I have facility to house housing my research project. So my research mainly focuses on robotics automation for specialty crops and precision ag applications. So some related project I mentioned here is one is robotic crop load management. I'll be working on different projects towards this direction. One is robotic greenfield thinning, and then have advanced robotic approach for pollination. That is Washington State was the lead PI for this project. And also precision crop load management for apples that Cornell is the lead SCI project. And also work some project on the precision technology for fruit crop production, especially on the irrigation system, and also intended sprayer system for the tree fruit. And I want to mention here, I have a few other projects supported by State Horticulture Association of Pennsylvania, SHAP, and then they are including also support the research areas in this I mentioned this two here. So first, I would like to talk a few projects on the crop load management. Here I listed pictures here is from pruning to harvesting. So it's very important to do the crop load management at the right time, and then so dormant pruning, blossom thinning, or greenfield thinning. Make sure every step is correct, and then we can eventually get a nice quality fruits at the end. So my project mainly actually go through pretty much all the process here. So I would like to mention a few here. So first, as crop bud detection at early stage, we did some image acquisition in the field and developed algorithms to identify the buds at early stage. And here's some kind of results showed here. we are trying to identify the buds from silver tip, green tip until the title cluster. And then now we are training the data, and we got around 70 to 80% of accuracy for the buzz detection. And for the flower detection parts, we also develop algorithms using the machine learning or deep learning technology to identify individual flowers or king flower detection and also flower clusters. That mainly purpose is for the target thing I will mention later. And also we did some of our work on the green fruit detection as well. You see, for this is for the green fruit thinning purpose. So we actually take images and did some of deep learning training as well for those green fruit detection and also the stem detection. Then we will develop algorithms to identify the orientation of the fruits, and then we will know what the requirement for robot to approach to the fruits for the thinning purpose. Here I will show a few prototypes, and then we did some studies on the robotic pruning. We developed two kind of prototypes. One is using the Cartesian, like the three directional X, Y, and Z robots, and you develop our 3 degree freedom end-effector that can rotate and cut branches at different orientations. The purpose doing that is to kind of minimize the space requirement for cutting mechanism that for the pruning purpose. And also we tried using this regular 6 degree freedom robotics arms to host to attach with a cutter system to do the pruning. So we did mainly for this work, we did for the mechanical part and control part, but we haven't integrated with the machine vision yet. We will do that in our future work. For the target blossom thinning, you can see we developed a robotic thinning system, like using a nozzle here. So the camera will detect the flower clusters, and then we will spray those targeted clusters precisely. So previous study results showed we have more than 50% of chemical thinner saving, and it performed well on the crop thinning. So we achieved pretty much similar results compared to the conventional L+ sprayer thinning method. Another one is green fruit thinning here. We also developed some prototypes for green fruit removal. So this is just a kind of the basic structure of the prototype, and we're using a cutting PVC pipe here to actually engaging fruits and have a cutting mechanism to cut the stem off. We actually integrate this into a robotic arm, and then we did some tests on the robotic arm, and we found we can cut more than 90% of fruits within using this mechanism. And then, so if you have a cluster of fruits here, you want to remove like for example, 4 out of 5, and then how you can engage in individual fruits with the path planning. So this is how we did the path planning, and then how to using this kind of mechanism to engage in the fruits. And also we did some precision automation for irrigation. So you can set up some irrigation sensors and with data logger and controller box. We used the IoT Internet of Things system to do the remote accessing the data, and also do the remote control of the valves for the irrigation, so that it can save water and human labor for the irrigation purpose. And then last one is some precision orchard spraying projects we have done in the past few years. We having this intelligent sprayer that using LiDAR system to identify tree canopy density, and then based on that, do the spray, control the spray nozzles accordingly to only spray the canopy, so that it can save up to around 50% of chemicals in our study. And we'll also add another airflow control at the back of the sprayer. This is using air damper system to control the opening of the back fan, and then we can control the airflow go through the nozzles, and then eventually can reduce the chemical drift. So the results should be significant, reduce the drift to the other side of to the next row by more than 50%. Yeah, that's pretty much very brief introduction of our research projects about related to tree fruit production. Thank you.
Thank you, Long. You, can you go next?
For sure. Let me share the screen. Can you see that?
Yes.
Cool, thanks. Okay, everyone. As I mentioned, I'm currently assistant professor, and I did not really mention I'm home at horticulture section. Well, from my title, you probably suspect why, a horticulture section or department gonna hire an engineer there. So that's exactly the reason I think this would be a great opportunity. I can introduce some of the recent digital ag efforts at Cornell University. Because we have a long legacy from ag and life science, and also back to early 90s or even 2000, we still have very active ag engineering program at Cornell. But after that, it seems like we're being silent a little bit, and people are wondering what is happening right now at Cornell. Is a kind of a totally drop the ball for that, or is there anything that really big is happening right now? And that's the thing. So before I really talk about my own program, I want to highlight the institute I affiliated with. It's called Cornell Institute for Digital Agriculture, short for CIDA. So back to 2016, actually Cornell recognized digital agriculture revolution is a great opportunity for us to get together, solve some of the grand challenges, not only for our agri-food systems, but also for many of the social ecological issues associated with. And that's the reason at that time, we did not really launch a dedicated single research program. Instead, we launched a strategic initiative called Cornell Initiative for Digital Agriculture. So with that, we hope to create a dynamic ecosystem to gather everyone, including faculty members, students, postdocs, staff, from the extension specialists, practitioners, stakeholders, growers, all together to see what's the grand challenges being faced by the modern agriculture, and what would be the next level of agriculture we should to achieve to make sure we provide adequate food, quality food, while make our environment sustainable and make our agriculture food system profitable to our growers. And that's exactly the mission of CIDA. And of course, we envision, through CIDA, we're going to create a hub to continuously foster new discovery, innovation, and communications among, all these different groups to make sure we do not only solve the current problems, but we are also envisioning what's going to happen in the next 10 to 20 years or even longer. And with that, in the past almost 6 years, Cornell has been very successful to run the Cornell Initiative for Digital Agriculture. And eventually, from 2019, we turned ourselves into Cornell Institute for Digital Agriculture. So as a very active institute at Cornell University, CIDA, the most recent achievement from CIDA was to receive the National Science Foundation Center for Crop Research recently, worth of $20 million for the next 5 years, which will enable us to reprogram the plants as sensors to tackle some of the grand challenges in agriculture. And also currently CIDA being supported across 5 different Cornell colleges, including College of Agriculture and Life Science, College of Engineering, College of Veterinary Medicine, College of Business, and also Cornell College, Bard College of Computing and Information Science. So with that, we hope we really not only rely on the cows to solve the fundamental challenges in agriculture, but bring all these technology aspects together to solve every single factor, not only the tools, but how the human factor plays a role there, how the policy making role there, and how our social economic gonna change based on the digital ag revolution. And so far, CIDA runs different programs. Like annually, we have 2 big events. One is a workshop that will be publicly available for not only academic researchers, but also growers, extension practitioners, and also private sectors and funding agencies. So we can sit together to discuss what are the critical things we have to resolve and what are the urgent things we must immediately give the response. Typically, that's during the fall time. So if you are interested in, keep tuned. We're going to share that soon. And also, we run the Digital Ag Hackathon every year during the springtime for our younger generations. So many of us recognize, okay, we lose our younger generation in agriculture. I think this, to me, as a technologist, this is one of the biggest challenge. If we don't really have the new younger generation join us, how we really make agriculture more sustainable in the future? And that's the reason CEDA at the beginning has this concept. We want to gather all these new, younger generation's attention. You can use technology to make a huge change in agriculture and food systems. And we want to gather them early enough so that they may even change their career goal that can dedicate for agriculture in the future. And this is a very big event, and we also run that through our A5 League, including UC Davis, Cornell, Wageningen University, University of Sao Paulo, and also China Agricultural University, that we gather the younger generations across the world to solve some of the grand challenges in agriculture. And also every month we run seminars, and those seminars being recorded. We talk about the cutting edge technology from the lab prototypes to very commercialization ready tools that everybody can enjoy learning some of the new knowledges in digital agriculture. And every 2 weeks, we also release our newsletter to give updates on what's going on regarding digital agriculture worldwide, so that you can keep updated with not only knowledge, but also what are the good events that you could attend that can benefit yourself. And eventually, as I mentioned, our goal is to gather all these different disciplines together, use all these excellence from ranging from agriculture, life science, to engineering, to computing technology, and to some of the socio-economic studies that can help us to better design the agri-food systems that can benefit every single participant, not only the growers, but also the public and other general people. And hopefully that will bring us to a new level to support our agri-food system in the next decades or so. So with that, I will turn to actually my personal research program, which is around this concept called One Ag. So basically what my research is doing is to add this technology layer between human and agriculture. So in the past, many of us who kind of run the orchards or maybe vineyards, we rely on our experience to make decisions and rely on our direct interaction with agriculture for harvesting or planting or various operations. Now my program is focusing on how we can create different technologies so that now you, in addition to your human evaluation or experience, you can have some accurate and objective measurements to tell you or to assist you make better decisions, so that you can make your orchard or vineyard more profitable and sustainable in the future. And specifically, I want to give some videos to give a demo ranging. I'm not sure if this is playable. Okay, so I can just explain and found the video later on. For some reason, technical reason, I cannot really play them. But basically, the first black window you see here around the left corner is about a indoor automatic microscopic robot. And that robot can replace the current microscopic observation for disease detection. And with that, we can support tons of the breeding programs now to cultivate new cultivars that are disease resistant or disease tolerant. And the key is the time, right? Because now we see all this disease worldwide, and we need to run them fast. And this robot exactly help in that way. And still on the left bottom corner, that's actually the robot running in the vineyard for automatic disease evaluation and mapping. So while the robot is running, we can in real time generate the map of the disease severity, so that later on, either you can rely on this map to make the decision on which spot you probably want to spray more, or for some of the spots you want to just delay or postpone your application to save the money and the labor. But the robot is ultimately to provide such information for you to do this disease management in the field. And also on the right upper corner, we see actually that's the progress of the hemp, industrial hemp. And we can monitor the growth and try to estimate the yield so that the growers can prepare the logistics early enough to save some of the labor and cost as well. And at the bottom actually is what I really want to show, but for some technical reason, it's just not play around, is actually a digital orchard. So basically we use a 3D laser scanner to digitize the entire apple orchard on the computer, so that you can see those detailed branch information and measure them if necessary. And this is a part of the precision crop load management project led by Dr. Terrence Robinson at Cornell University. And we try to better understand the tree architecture so that we can use that to estimate the optimal crop load first. And then we can also transfer those information to other colleagues, like what Long just illustrated, to guide the robotic pruning, so that we can know exactly where we can cut. And also now we are working with some modeling colleagues that to simulate, okay, if we cut the branches from different levels, or we just totally cut different branches, how the apple tree will grow and how that will impact the apple fruit quality eventually. And through that simulation, we hope we can just better determine which of the branches need to be cut, and that can provide the best benefit for you. I'm gonna just stop here, and if you are interested in, feel free to contact me directly. I guarantee I'm gonna share those videos with you.
Thank you for that presentation. Matthew, your turn. Yeah.
Okay, can you see the slide here? Slide?
Yes.
Yeah, super. Thanks again for your leadership in organizing this. This has been this is fun so far. Interesting stuff. Nice to see what's going on around the country as well. I'm going to just wrap up these introductory comments with a few points and ideas that I've developed over the years that I would suggest might be important for thinking into the future as we attempt to mechanize and try to do so successfully in tree fruit production. And again, coming from my bias, I am an applied whole tree physiologist, and so this is my point of view. I'm not like you and Long as experts in engineering. So I'm going to start with a list here. I've actually got a top 4 here. And my number 1 suggestion or concept is that one would need to take a total systems approach. And this is a phrase that you've probably heard before. And in essence, it simply means that we can't just have engineers working in solitude, and we can't have horticulturists or others working in solitude. There needs to be a team approach to this, otherwise known as multidisciplinary or transdisciplinary approaches. And I've just suggested a few disciplines here, and these are some groups that we've put together in the past as we've pursued funding and made efforts to try to address some of these issues. And they include economics, looking at true cost accounting of technological innovations. Certainly rural sociology becomes critical as you think about farmers' attitudes and opinions and adoptions and successes when it comes to even commercialization. Engineering, horticulture, these are strengths. Molecular biology is one maybe people don't think about, but can be critically important as well as part of this approach. Breeding and genetics tends to be a longer term effort, but I think when you think about the examples that we've seen so far, that if we can understand better and develop crops that are better suited whether it's growth characteristics or fruit quality traits, then we're further along towards having a successful system. And post-harvest and marketing and storability, and these all become part of the scenario. This is how the USDA Specialty Crop Research Initiative describes their total systems approach. It's got production, it's got an area on consumers and markets, and distribution and processing. And that spot in the middle there is what they're calling as a total system. I couldn't find an icon, or couldn't recreate 3 circles myself, so I just used this biohazard logo. It's not to suggest that there would be any biohazard in bringing together social scientists and applied scientists at all. I'm going to give you one quick example here that we've done. This is work that we started with an SCRI project in 2010 towards mechanical harvest of fresh market quality sweet cherries. And this frightening image on the left is one of a traditional old sweet cherry tree just after pruning. And so we had to think about renovation of orchard systems, and we did that. On the horticultural team that I was leading, we developed a new architecture called the UFO that you see here. It's perfectly well suited to match new harvest technologies. So on the bottom right, we went from people carrying ladders and picking buckets, and now we've redesigned that entirely conceptually to a mechanical harvest process in which you're sitting at an operating station and maneuvering a shaking arm onto a catching frame. And then we had to rethink also the fact that rather than, as you see in the top right, these cherries with lush green stems, we were now, through these technological innovations, harvesting stem-free cherries. And so that became a part of this total systems approach. We had to look at packing and sorting and how these cherries without stems would handle the existing commercial cold chain. And ultimately that led to innovations in packaging and marketing of stem-free cherries. As one innovative commercial partner on this project had developed and even patented as the Cup O cherries, as one small example. The second one that I want to put forth for you to think about is to consider scalability. And I'll give you one further example. But if you take a look at this prototype mechanical harvest system for sweet cherries or other fruit, we, with economists, came up with an estimate and said, well, let's say this is going to cost about $200,000. That brings up the question of who can afford that, right? So there's a big farm, and it's got the green light. Big farms can probably afford this scenario. However, you can barely read that because, as you can tell, that's a small farm. And it's in red. It's got the red light. It's not going to be affordable for smaller holders. So I have to think about those items and how do you approach that from the beginning and plan for that from the outset. More posing questions really than providing answers here. But one way that we approached it on this mechanical harvest project was adopting the same concept that you saw in the large, expensive machine. And now we're testing that with handheld battery-powered shakers combined with handheld catching frames. And we're looking at myself with a student here a few years ago. And on the top right, there's a short video of some work that was done just a couple of days ago with a new catching frame surface here. And the neat thing about these technologies, if you reverse the direction of the shaker, the fruit will actually fly back up onto the tree, as you can clearly see from the video. Yeah, of course, that's not true, but it's just looping back and forth. And the other neat thing about this approach is it allows us to access, I would suggest, nearly every orchard in the state, including those that are traditional architectures, as you see in the bottom right. So this is a way of addressing affordability and scalability. We're also interested in these mass harvest approaches that you see, very distinct from the robotic harvest approach. And this video on the left is cider apples. We did some shake and catch work with cider apples the last couple of years as well. And there is still interest in shake and catch approaches for dessert apple harvest too. So that's something that we're pursuing a little bit further. And maybe this goes quite well with point number 3. That is, we think about this in the long run, it's probably a good idea to avoid costly or potentially costly single-use tools. And we need to reconsider from the outset how we might build in multi-functions into these systems for the future. What you're seeing here is an example of a partnership that we have at CPAS with FF Robotics, a commercial robotics company out of Israel. One of the groups that, as Inez mentioned, will be testing their systems again in Washington. This is their 6-arm robot system for apple picking, but we're working closely and have concepts in consideration for funding where we could switch out the harvesting arms and put in a thinning one like Long was showing, or put in a pruning end effect, or even pollination, or even simply take off the bin handling processes and put people on there if there are very delicate work that needs to be done. And this becomes a mobile platform, for example. And the last one that I want to suggest is that the fourth one is don't plant another orchard. And I finish that sentence would be that unless you're thinking about what's the situation going to be in 10 to 15 years into the future, and you may say, well, that's very difficult to predict, but there are some things that we know for sure. We're not going back to this situation of 30-foot wooden ladders leaned against the tree and climbing up and picking fruit. This is well into the past, thankfully. As we move to aluminum compact ladders and more efficient orchard structures, but still with buckets and moving up and down. And we know that we can gain incredible efficiencies just by doing so. And our vision from the horticultural side has clearly evolved to one of compact fruiting wall architectures, whether in a V or an upright configuration. But we need to think about then in the interim, as we think about walking before running into full robotic harvest, how can we build structures that suit very well with mechanically assisted technologies, such as the platforms that are almost becoming ubiquitous throughout the Pacific Northwest in modern apple orchards. And here in a UFO cherry orchard I took just about a week ago as they were picking early robin cherries here. And what's on the horizon? Tevel, another robotics company out of Israel, is testing out their drones for harvesting apples and dropping them into the bins. And I mentioned our partnership with Avi Kahani here. He is here with his system, robotic arm system, looking in orchards as well. So think about this. Think about what you need to be, how you need to be successful in 10 or 15 years in building the structures and all the exciting technologies that will be coming forth. And just to wrap up here, specific projects that we're engaged with. One is looking at robotic pruning, and that's in UFO cherries as well as apples. We've partnered with a couple of other institutes on robotic flower and green fruit thinning and apples. We're looking at, as well as with Dr. Long He and this robotic pollination with liquid pollen suspensions, and also looking with some colleagues here at WSU on soft robotics. So rather than this 6 degrees of freedom rigid arm that you see here, a soft and growing robot system. And I'll just finish with a quick video of a successful pruning cut made in one of our UFO research orchards. And it was terrific to see this happen because it's the culmination of horticultural work with engineering work and working collaboration with industry in our area. So with that, I'll close and look forward to the remainder of the conversation.
Yeah, thank you everybody for the great presentation and looking into the future. And as Anna mentioned at the beginning, in the previous session, we were talking about implementing irrigation systems and monitoring systems. My question for all of you would be, what has limited the adoption of this technology that we know already are in place? For example, automation in irrigation or monitoring systems or drone system. What has limited that adoption in the real world? And before you start answering that question, we're gonna do a poll. Anna, are we ready for the first question? So the first question that we are asking our audience is, what are the barriers that you think you will have to implement a mechanical harvester in your operation? What is the most important barrier that you consider will prevent you from implementing a harvester in your operation? So if you're on your phone or if you are on your computer, you should have that question there, and then you can select your answer.
I'm just double checking. Can you guys see the poll? I'm still not seeing any responses, so I just want to make sure that it's working. I don't do too many polls in the webinars that I've done in the past, so this is an exciting new application. All right, it looks like it is working now.
Now it's coming. Yeah, now we're getting some answers. So.
I think there's also a little delay in this, so we'll give it a little time. I think it's also showing all 3 poll questions at the same time. It doesn't separate them out. Sorry about that. So the follow-up question after you think about barriers to adoption, the next question that we're going to continue our conversation about is, what do you find most valuable or most important when you're thinking about new technology? And so there are a few options for you there. And then the last question is about, what kind of support do you want? We have all of these experts on that are doing this kind of research, and extension specialists that are trying to communicate the research to a commercial level. What kind of support do you value or would you like in adopting this new technology? So if you could provide some feedback on all 3 of those questions would be great. We'll just give it a couple, maybe another minute. Or we could leave it open if we want to start.
Yeah, right.
Our panelists.
Yeah, so now that while we keep the poll open, I think I will start with you, Matthew, because you had a system approach that you show the product of the shake and catch for cherries, that it was adopted by a couple of growers, and I wonder why it's not completely adopted in our industry. What do you think is the limitation?
Sure. Yeah, for that specific example, there's a couple of reasons. The reason that the fully mechanical process hasn't been adopted was pretty straightforward. It requires, if you remember the photos of that system, it required a very, almost quite a flat V configuration. So the horticultural side, we worked on that. We developed these systems in the orchards, and it worked actually very, very well. In fact, our data show that any one of us operating this machine harvester versus any one of us with a picking bag was going to be 50 times more productive running that machine. So it's staggering the potential improvements in efficiency. But there were very few orchards that were configured to that V system, and that really put a halt to it. And so that's where you've got to think about transitioning over time, and how realistic is that to ask a cherry grower to say, well, could you please take out these orchards and transition and make this radical change? And so that's where we stepped, I think, in the interim to these handheld, human in the loop or mechanically assisted processes that we think are far more scalable and affordable. And actually, we're working on a project just now with a local engineering company to work on the prototypes to have those available. And the second, the second part to the lack of adoption was also on the consumer side. This is why we see it's quite clearly you need to consider the whole system, and that was a misunderstanding, I would characterize it as, on the potential marketability of cherries without stems. It sounds like a very, very subtle thing, a cherry without the green stem, but it was. We did a lot of studies with this and found that consumers will buy these fruit and they'll pay the same amount or even more, is kind of our vision. But it was the marketing buyers who were a little bit uninformed, and that was kind of the roadblock. So all that's to say that we've identified, I think, these limits to adoption, and by addressing the full system. And so now, as we're moving forward, we're tackling those roadblocks.
Thank you, Matthew. I would like to ask the same question for Long, and you especially mentioned that you were talking about irrigation systems, right? And irrigation technology. And some of that is already developed. And what do you see the limitation? Why we have not every one of us have already a system in place and an adoption of that technology?
Sure. So I think for certain technologies have been kind of I should say well developed, and then it's supposed to be ready for adoption, but it hasn't to be widely adopted or something like. So there's few reasons as I can imagine, kind of based on my kind of conversation with growers before. So there's limitations on the growers kind of their infrastructure, for example, right? So if they are we're trying to use an automation for irrigation, then their irrigation system need to be kind of using certain type of electrical control system, for example, and then their pump system need to be using more, can be adapted to the controller system. And there's another one reason that it can be is they need more the convincible success stories for them to adopt new technology, even for irrigation, like sensor-based automation irrigation. So they want to know that is that cost effective for them to use, or how much benefit they can gain. Is so there's should be more kind of they want more kind of stories from other growers or from other applications, and then those information, I think extension from university could be kind of provide more information in the future. So kind of have more convincible material for them to consider about adoption. So there's another limitations is also the technology side is reliable, and robustness is also very important. So the growers wants something to be used in with consistently working properly. So if there's any kind of the problems, issues, or some challenge during the operation, then they will be hesitant to adapt. And then if it requires a lot of skills to use them, they also have some kind of hesitation to adopt. So in order to do that, I think it's very, very important to develop some kind of to develop technologies that can be easily used and also user friendly, I should say, and then and also the support for service and other kind of information need to be followed. So those are some of my thoughts.
Thank you, Long. You or Ines, any of you, do you have anything to add to that?
Yeah, I want to just chime in and echo what Long just mentioned, several aspects from my experience. First is the upfront cost. To me, I think this is really important because, like, for example, I'm not sure if you all are familiar with the NUA system in the New York State, and now being widely kind of spread out across the country, try to use the weather station data to associate it with some of the prediction model to tell the growers when you need to irrigate and when you need to spray, right? It's a kind of a low-cost monitoring system. But when I kind of approach to our stakeholders here, and a biggest concern from them is NUA never reached out to the resolution they need, right? Because that's a kind of a statewide or even national-wide weather station network, rather than I'm looking for the particular part in my orchard. Or even you can tell me my orchard needs to do something. So then, if we ask them to, install some of the sensors, then that's the upfront cost. And that's related to many things. Whether or not my kind of investment gonna give me the benefits in a short term. Because I mean, so far the profit from agricultural produces, even for those value-added crops, is still marginal, in my opinion, compared with other industry. So I would see, this becomes very cautious from the growers to consider if they need to pay that upfront. And also, I think that's related to the agriculture workforce development. As Long mentioned, not only just for the sensor system, and if later on we talk about the robotics systems, we do not only need the traditional mechanical skills, that, for example, now you can easily find some of the workforce for your orchard to maintain a tractor. But if you are talking about those electrical systems, those information systems, who has the right skill that can be, in an affordable, salary or compensation that can help you or work for you to deal with this? And to me, largely, there is a huge gap from the educational perspective. And that's something I think from the university, we definitely could offer, like a workforce certification development program to help us to train more, skilled workforce that are dedicated for digital agriculture. So they do not only understand basics in agriculture, but they also have at least one of the right skills to help you deal with those robotics or sensing system in the future.
Thank you.
Yeah, I guess I just want to add a couple of things, and that's related to ultimately how you get somebody to adopt. I think, and ultimately, it's still in terms of when is somebody willing to kind of consider something. There's still a lot of this grower to grower talk going on. So ultimately, if one of your friends is doing this, or when he says it or she says it, then it counts more than any scientific data you can possibly throw at somebody. That seems to be still really, really important. We've seen this time and time again with a lot of different things where all the information has been out there, but until and when growers actually, somebody starts using it and then talks with others about it, it's not going to really go. On the other hand, I think Drew's idea about workforce development is great, but I think there is another way of learning. A lot of farmers are quite astute of learning on the fly and their workforce learning skills as they need them. So oftentimes what companies don't consider is having first like a system where they basically do bring the technology and do everything for the grower. And then as the grower becomes familiar with the kind of thing, then the grower would take over, for example, driving the machine or using the sensor itself with some support. And then ultimately some people might even advance to run the system themselves. That kind of stepwise approach has worked really well, but that's often with startup companies difficult because you need to have some people in your company that help. And ultimately, I think the companies that do best, they have really, really good customer support, so that when something breaks or if something happens, you have somebody that constantly is in contact with the orchardist. Otherwise, it's just not going to fly. I think those are really important things. And otherwise, it's things have to be rugged and they have to work in the climate. And oftentimes that's not the case either. And then, yeah, if you have too much downtime, you're right away, or you're kind of turned off.
Thank you. And maybe following on the same idea that you were talking about, when you start developing this new technology, how you make sure that from the very beginning you are targeting that need, that it can be adopted. So I'm gonna go back. Maybe I know that Matthew has examples of success of that process of adoption, and maybe you can share some of those examples from just changing that systems. How did you manage to go from the research side to actually that extensive adoption with the grower?
So I think one of the things that I learned quite quickly when I moved out to Washington State was partnering with industry from the beginning and from the outset. And if you haven't, and if you think you've got a great idea and you put in your proposal and try to get some work done on it, and a lot of times you're spinning your wheels. And that's actually one of the nice things, of course, about probably also where Long is working out at the research and extension centers. We're really surrounded by growers and very innovative and forward-thinking people, and just making sure that you have your concepts well grounded. And I always considerate that there's a pain, right? That the industry is hurting somewhere, and you try to figure out what that is and how you can help relieve the pain through some technological solution. And so I think that's really the key to it. And then another one that really is useful is then partnering with a existing commercial entity, and not trying to develop something independently as a university, but saying, hey, there's people out there who have very different objectives than you do as a research leader or as an extension specialist. And their jobs are to develop something that's commercially robust, as Inez was saying, and reliable, and provide support and sales and distribution. And so I think those would be two critical keys. Get involved with industry and make sure you're addressing something that has value at the end of the day, and that also that you've partnered with commercial entities. And I think the work that Inez is doing with building these consortiums with the commissions and what I hear from you as well sounds really encouraging in that regard.
Thank you, Matthew. There was a question in the chat that I don't want to miss before we move on to the next questions. This question is for you. It says here something about the sprayer, that are there concerns for safety for these autonomous technologies that you show? I think he's talking about the automation in the sprayer. Will these systems ever become subject to third-party oversight, such as OSHA regulations for who can operate the equipment?
And if I could broaden that question a little bit, if you could answer specifically about safety, but if all of you have sort of started touching on this, what considerations should growers or operation managers be thinking about as they're implementing things for their workers? So we've talked a little bit about teaching and learning new technologies. What other things should growers be thinking about? Safety, ease of teaching, what other things related to their workers should they be considering? So I think, was that a question for Long? You had talked about the sprayers. Do you want to start?
Yeah, I think the first question is come up with claims. It's about the safety about the sprayer to control the airflow. I think later on, to extend this question to general, like the safety for the agricultural equipment operation, that other panelists can be chime in later. So for this one, yeah, I think it's a very good question. For this one right now, we are still doing the prototype test. So we did some tests in our orchard here, and we didn't find any. We didn't find any kind of issues with the control and the damper for the airflow control. Yeah, that's a good question. Like seeing if you are like the regular size of the fan opening is large, and then when you reduce the size, then it could generate some of the cavitation. That is something I should look into in the future, but I haven't heard that yet. So it's possibly a good point to pursue, I think, for the safety purpose.
Well,
I'll just add very quickly, and then it's just very quickly that as part of this this total systems approach, I mean, I couldn't list everything out there, but I would suggest that somebody in occupational health and safety should be involved as a partner in these robotic and field app when humans are involved, certainly, because none of these new startup companies are going to want to have that headline of the worker maimed or injured in field by autonomous robotic tractor or something. So it's an important element, absolutely.
Yeah, the Washington State Department of Agriculture has already put out some guidelines for autonomous vehicles. So we've been really proactive partnering with our State Department of Ag. So they are very aware of everything that's going on. They're actually really quite frequently actually visiting all of these sites. They will do this next week with a big group of people, so that that the legislators are up to date on what it is that they need to be legislating in the future. I think that's a really important point. I think another point to think about is the fear factor. We often hear from advocacy group that, oh, we're going to take jobs away from people. And there's still a cultural thing. I mean, and especially here in our orchards, that, or in general, like folks are worried that their job somehow will be gone. And if that fear is the case, then it's less likely for something to actually work. And so that needs to be addressed, and that the time needs to be taken to explain that to people, that so that there's the understanding that actually will make their life easier. And then there's some very practical things to consider. For example, the display needs to be readable in the sun. If you got some sort of a device that you can't read in the sun, you can't use it, right? That thing, anything needs to run for at least 8 hours without any problems, and dust should not be an issue. And we have a lot of dust here, so dust kills everything out here. So it's, some of these things are they sound really simple, but they're not as simple when you take something out in the field.
So Ines, to that comment that you just made about the fear of new technology that is taking out some jobs for people, what would you answer to those that have that thought? What would you say?
Well, I would say that ultimately it actually creates, technology has the potential to create a more pleasurable work experience and take out the really backbreaking parts of the job that are mundane, and enable year-round employment in a situation where it's not backbreaking anymore. I think one of the big chances we have with using technology is to have stable employment for a year-round team of people that would be able to manage the orchard. Right now we have these tips, right? We have these tips where we need a lot of people for pruning and for thinning and for harvesting. And if we can go to a system where we have a steady workflow that is spread out across the whole year, that would be a much more sustainable way to operate, and it would and it would take care of a lot of the issues, and I think it would also help manage the trees better ultimately, because quite frankly, winter pruning is probably not the best thing to do in most situations, in most orchards, but yet everybody does it because that's when the time is there, and so there's lots of creative ways, and it will open up the workforce pool a lot for having, if you don't have these jobs where you have to lift 50 pounds or where you have to do these repetitive tasks. I think it makes it a much more pleasing work environment.
I was wondering if now I could, thank you for your answer. I just wanted to transition and maybe show the results of the poll, because it's reflecting really nicely what I think we're hearing in our conversation. So in our first question, we asked the audience about the barriers to adoption, and the upfront costs and the high cost versus benefit are the leading sources. And there wasn't really a problem with lack of knowledge or difficulty training, which is what you guys are saying, is we've got to figure out how to manage these costs and make them adoptable for smaller scale orchards. And but they don't seem to have trouble with training people. There were some other responses for all of the questions. So I'm wondering if you wanted to type in the Q&A, what are the other barriers to adoption that you see for some of the technology that are coming in the future, or maybe existing technology? And then I think the second and third questions reflect as well the importance of cost in these new technologies and making sure that we're reducing the cost of production. That's the most important consideration in adopting new technology by far. And then looking for support, looking at a cost benefit analysis is one of the top responses, as well as having excellent demonstration orchard projects like the Smart Orchard. I think that's a really valuable site that you have, and envious we don't have one in Michigan. And then continuing to provide workshops about the technology so we can convey that information. And you mentioned this as well, seeing other people do it first, that communication of knowledge from grower to grower is so important. I put a little goofy smiley face next to that, but I think that's a really serious, important way of communicating information. Are there other things that weren't in the poll that were important that if you'd like to include them, participants, if you put them in the chat, we'd love to hear them. Otherwise, I think maybe if we wanted to transition to another question, did you have something specific you want to lead with, Bernadita?
No, I just wanted to ask the rest of the panelists if you had anything to add to that answer that Ines just gave about the concept of replacement of people.
Yeah, I just want to chime in on that because basically I'm working on AI system, and that's really the reason fair for everyone, not only for agriculture, right? Because when we hear AI can do this, that, replace all human power, I mean, everybody fair, even myself. And the joke around ourselves, who are doing the AI is AI perhaps is replacing all the AI researchers first before replacing other people. So no worry here. But I think, from the more positive side, I would say actually all this technology would create new job opportunities. I would say definitely it will kill many jobs in this round of revolution. But of course, it's because of those jobs are in a dangerous situation. For example, if I kind of have an orchard, hire someone to spray the fungicide, it's very likely that worker, if not wear proper PPE, or if doing that operation in extended long time in the field, it gets some dangers related to, personal health issue. It's not that pleasant. It's a kind of during the daytime. I'm not sure where you are, but like I used to be in Georgia, and the summer there is awful. It's just hot and humid, right? And it's just basically those jobs are not really great, and you also being paid with very minimal thing. With all this technology now, the job opportunity turns into, okay, in addition to operate that system, now you need to maintain the system. In addition to be in the field, you teleoperate it under a more pleasant, situation and gather more information to make smarter decision rather than all this, pure labor work. And I would consider, that will also give all of us another round of opportunity for continued education for yourself. So very short answer from me is it actually created more jobs for you and give you a better opportunity to use more skills and knowledge to solve the hands-on problem. So don't fear about losing those bad jobs. We're going to have more great jobs for you.
Thank you. There's a good suggestion here that maybe comes in the order of the barriers is to focus on the supply chain for parts of something made or at home or overseas are a big issue. So think about that.
True.
So the last question that we had in our poll was related to what kind of support do you need to implement these technologies? And I wonder if we could ask that question to the panelists. What is the best way that we can utilize university support, but how can we best utilize resources at the university level? Or the flip side of that, what are the biggest challenges that universities face? Do you have examples of, we talked about this being a really long time and a really big cost investment from conception to implementation at commercial levels. So what are the big barriers or challenges at the university level that maybe we don't see all the time? And what is the best way to utilize university knowledge and resources?
I'll take a crack at it then, I guess. So I would suggest it goes back a little bit to what I was saying previously, that in my opinion, universities shouldn't operate independently, that there should be partnership with commercial entities, because in my experience, that's provided the best balance. Universities and faculty are rewarded in a sense, right, for very different things than a commercial company is rewarded for. Where part of our mission is to train graduate students and postdocs and have publications and turns into another grant, and have that cycle continue. And that's really, I would suggest, almost not quite, but meaningless to a growers. It'd be nice if there's some graduate students that are trained and can plug into some of these jobs that you is talking about. But the role, I think, I find it more and more often, for example, with our Center for Precision and Automated Ag Systems at WSU, where we originally conceived of it as being leaders in the development of new technologies, whether it's sensors or AI systems or a robotic arm. I think now we've changed that vision considerably to really the role that universities can play is in, I like the way you described it, and what they have there with the center is to create a hub and be the force for collaboration and play a leadership role there and say, hey, I see these moving parts and we can play a leadership role in bringing them together and helping to foster the collaboration and provide leadership in providing that venue or the hub for the collaboration among private and public partners as well. Actually, a lot of what Inez described that they're doing with the collaborations as a leadership role there with the Western group is a good example of that. But I see it more in that really contributing in detailed efforts of AI or robotics or horticulture or social sciences where necessary, but also providing really more of a coordination and it might be a bit cheesy, but even an inspiration role of bringing people together and trying to create those teams.
Yeah, I also want to add one point here is like one of the challenge for the university research group is like the continuous of the effort into one thing. So that relates to the funding. So we are kind of sometimes, for example, if we have a project working for 2 years, 3 years, and then suddenly we're losing funding for that, and then we are actually stopped for at some point, so couldn't move forward. It's kind of challenge, but then it's like I think I agree with Matt just said that university provided some concept and then also some ideas that I can actually collaborating with other party and then to move things forward. That's I think it's a good point.
Thank you, Long. And I'm assuming that you both mean that collaboration with private entity includes also working from the very beginning with the grower, right? Not only for the companies that will supply the technology in the future, but also having the grower involved from the very beginning, right?
Yeah, for sure. I think there was a question that's popped up somewhere about maybe products from the companies being oversold. And I think that's where the examples of the smart farm can provide, I think, a good model, though it's not testing yet necessarily robotics technologies, though it could and may, more of a sensor-based approach because growers are inundated with these options. And it provides, one would hope, an unbiased evaluation and assessment of potential commercially available tools where you can compare them side by side and say, well, this is what we are seeing, the data that are generated and the utility of those data from different sensors, for example. So I think that's another key role of universities is evaluation, comparison, and providing via good extension programs the data that growers need to know.
Yeah, I 100% agree with Matt about both things, especially about the evaluation. Actually, at Cornell, we got some announced a new initiative called Digital Agriculture Trials for Adoption. So that new initiative is dedicated to evaluate all the available digital ag tools that can solve some of the priority or urgent issues facing by our growers. So I would say without that, many of the growers, many just don't really have the channel to understand those information. And from the technology development perspective, I do see many of the startups try to approach to our growers directly, and the feedback from the grower is very mixed. Some of them do have very successful story and start to share with their friends, and gradually we have a bottom-up approach that let the university pay attention. Okay, there is a great technology that we need to, through our extension channel, for example, to really spread it out. But also sometimes we do hear the feedback from the growers. This company approached me, spend 2 days in my orchard, collect some data, disappeared. And if more than 3 companies like that approach to the same grower, the growers start to think about, no, I'm not gonna do that anymore. And that's where I'm really concerned about. If our growers lose their patience with the technology, with all the possible tools they could use to benefit themselves, and I don't know how we can really, recap that with them. So that's the reason I think a university now is really plays the important role here, because we stand for our growers. We don't really, stand for the profits from the companies. We stand for to bring the best tools for them to solve the right problems. And for some of the issues that we just, see from the poll, actually upfront cost can be shared somehow, by many growers or grower association through various, funding, possibilities flow into the university, so that everybody can see the objective evaluation for various tools without those upfront costs, or without some of the burden, by being contacted by so many different tech companies just to a single grower. And also through some of the extension events like the meetings or workshops, all this information can be distributed to others. I think that's how I think university could play kind of a central role here, try to connect all these dots together, build really trustworthy channels to share the information, rather than let them just self-organize. Sometimes that's just not that successful.
Thank you, Yu. And I would like to add in our role that we have in extension, that with the meeting that we have in the last session, we also learned that a lot of the growers are doing and evaluating themselves the new technology. And so sometimes we want to do that maybe in a research setting or with a grower that we want to evaluate that, but growers are doing that on their own. And I wonder if as extension and researchers, we can actually provide some support on guiding that evaluation. In my area, I focus a lot on the ground truthing side to be able to help the growers to have a path that is easy, not too distracting, so they can evaluate the technology on their own environment. Anna, we have 2 minutes left.
I know the time goes so fast. We have so many questions for you. I guess, do we want to do one last round robin? And what are you most excited about, or what's something you haven't had a chance to share yet? What should people be thinking about and leave this webinar with related to new technologies that are coming down the line? Would you each like to have 1 more minute to give one more takeaway message? Would that be all right?
Sure, I'll start. So I would say the cool thing is that everybody that farms is already a data miner. It's just that we haven't thought of this in the past as us as data miners. And you have a lot of farmers still have that in their head or maybe on some scribbled on paper. But ultimately, everybody is really good at data mining. Now we just have this chance to assist ourselves, so we don't have to have this all in our heads anymore. And I think that transition is less, I think we should be less fearful of that. But in the process, I think we need to not lose our green thumbs. It still will be very, very important for everybody to know how to keep a plant alive and to understand a plant, because we have a constantly changing environment, and while technology can help us, we still will need the human in the loop. So I don't think there's any chance that humans go out of the loop anytime soon when it comes to plants, because plants evolved to stay in one place. Well, they stay in one place. That means they can do everything in 50 different ways. And this is still a big mystery. And for that, we still need some humans to observe this, because there's no algorithm that I think we can develop to totally be plant whisperers. So I think we all have a future to stay, but we got to consider becoming good data miners.
Thank you, Ness.
I would be the second. Actually, well, I'm an engineer, but I will share the most exciting thing to me so far to see the future is actually people, not the technology. I mean, everything being developed by Earth people, and every technology being adopted by Earth people. So as long as people start to realize this is critical, and we have the passion to really further this direction, I think we would have a brighter future. And that's how I really see from the recent Cornell Digital Agriculture Hackathon. We have over 200 undergrad students directly talk with our New York stakeholders and growers about their on-farm issue and propose different technologies to them, try to tackle those hands-on issues. And that's exactly I see how people work with people to bring new technologies, to bring new concepts, to solve some of the grand challenges that would, impact the people in the future. So I would see people is the most important thing. And I'm excited about that.
Thank you, you.
So if I would like to have a little bit takeaway message is like, I hope our growers keep interest on the technologies, and those can be from just simple sensors, or go to information collection, and there's some of decision support apps or other kind of tools that actually can help you to reduce a little bit kind of your human effort to make things a little bit easier for you. Or in the long term, can be go to like robotic system for many kind of operations. And also, I would like to also mention, like in between the manual and the robotics, there are still other solutions, and using like human assisted platform or using other kind of tools that also can be helpful. So keep your interest on the new technologies, and we are as a university and this extension specialist, we would like to provide more information and help. Thank you.
Yeah, so the last one always says the challenge of coming up with something that hasn't been said, eh? But I like what each of you have articulated, really good points. I actually, the first thing that did come to my mind as well, was people, and thinking also from the point of view of workers and jobs and the rural sociology aspects of systems and technology. I think I'll just suggest that this is inevitable, this direction, right? I think we're just, if you're looking at a curve where there's so much interest and it's just starting to take off. So I'm really quite enthusiastic about building teams and collaborations and seeing what's going to come out of this in the next, even just 5 years is going to be pretty exciting. And then I think it's going to be begin to snowball a little bit, and there'll be a lot of new players and a lot of exciting systems that come in. And they're only going to work if we do follow that approach of teams, collaboration, looking at this whole system, private partnerships, but also it has to be driven. It has to be driven grassroots, though, right? So I would suggest that each of you who are connected as a grower stakeholder look for opportunities to participate and provide feedback. I think that there's fantastic extension agents around the country, and they're usually pretty open to your thoughts and ideas. So get involved as you see fit, and where you have opportunities to provide the feedback to help drive this bus in the right direction, so that things actually are going to make a difference for you. And I'm excited to see what will come of this in the future. So thanks for organizing it and including. Appreciate it.
Thank you, everybody. And because this is the last session, I think maybe we can do a round if any one of our co-organizers, Daniel, Christy, and Mario, have anything to add.
I feel very excited that we are finishing Bernardita, Anna, with all these great comments about the role that we should have, perhaps, in the adoption of the digital agriculture technologies. What you, Jan, was mentioning, I think is key. It's a learning process. We are all learning in our respective Grand Land university systems. And I think so. This is so huge, so amazing that we keep track of what we are doing. No, it's everything with machine. It's at the end with people. And again, I agree with you. You mentioned this, how important is that we continue working together, like we have been, Bernardita and working together through our respective extension systems. I think it's a lot to do because there are so many technologies that are hitting the growers, that are coming from the sky, and we can do a better job, I think so, in bringing more unbiased evaluation for the good of our stakeholders across multiple commodities, definitely. So I feel very proud of what we have been able to accomplish in this series of meetups this season. Congratulations to you, Anna and Bernardita, today for this closing. This has been great.
Thank you,
Thank you,
Mario.
Mario. But it's been a team effort and pulled together by a lot of people, and people beyond this group too. I would just echo what Mario has said. This kind of work, I think, has brought together people all over the country. I know I'm part of a couple of groups with amazing collaborations and really inspiring work by the university level. And I learn from my growers every day some of the innovations that they're making, and the companies that I've gotten to be involved with. I see exactly what you're saying. It's a really exciting time for a lot of people to come together and work together in unique ways. So I'm excited about that. And thank you, Mario, for, I think this was your brainchild, this virtual webinar meetup that came out of the pandemic, that we could only meet virtually and have conversations. And I think it's been really positive for a couple of years now. So thank you, Mario. I don't know if Christy or Daniel, if you wanted to say anything, or we could just wrap it up. We're a couple minutes after the hour, but if you're there, welcome to.
I'll just toss in the comment that was made earlier about worrying about workers and putting people out of jobs with automation. That's always been a fear. But I think that, as was made earlier, technology is just going to change the way people work. And in a lot of ways, it's going to be better, for the better. And we just need to keep that in mind as we invent things. Technology it can be feared or it can be embraced. And I think that what we're seeing here with these different programs that are involving growers, engineers, academics, academians, everybody's working together, and I see a bright future for this industry. I really do see that some of the things that are coming out of this will really make people's lives a whole lot better. And, if you're concerned about, machines putting people out of work, I don't see that happening. I see people just changing what they're focusing on slightly, and they will actually benefit in the long run from it. So, this whole webinar series was about labor and technology, and they will always be hand in hand. That's just my concluding thought.
Yeah, I'm happy to add just one final thing. I know we're pushing the time here, and I think, speaking from Ontario, Canada, I think it's been really wonderful to see the similarities, both in struggles, the challenges, as well as some of the successes that these industries have had across both Canada and the US. So I think this has been a really great discussion, and it's been wonderful to be involved and to kind of foster some of these potential collaborations, because I think that we're all facing very similar things. So thanks.
Bernadita, do you have any last thoughts you want to add before we just say goodnight?
No, everything has been said. So thank you everybody for the participation, and especially thank you to all our panelists and our grower panelists that are not all of them are here today, but this is a collaboration, a good effort with all growers and the researchers. So thank you for being here with us. And we're gonna be sending a survey after this meeting, and we do want to hear from all of you attendees. What is the topic that you would like us to cover for the next season?